All right, so I'm going to demonstrate here how to perform the Fisher's LSD protected t-test for multiple comparisons after running a one-way ANOVA in Excel. Okay, so we've got three groups here that we want to compare, group A, group B, group C, and this is just fictitious data. And the first question that we'll answer is whether any difference exists between the means. The null hypothesis being that they're all equal. The alternative is that at least one of the means is different from another one. So we will perform a one-way ANOVA using the data analysis tool pack. Select ANOVA single factor, click OK, select our input range here, and this is grouped by columns, and so we're going to make sure that is selected. And I'm going to select an output range. You could also have it open in a new sheet. I'm going to select this for the output range and click OK. Okay, so now we've got our ANOVA output. Now, the first thing that we're looking for here is whether our F statistic is significant or not. This is a large F statistic and a very small p-value. So this is a significant Omnibus test, and these so one of these averages is different. At least one of them is different from another one. You could probably guess which one it is. Group B is probably going to be different, but you want to, before performing this test, you want to determine which of the comparisons are actually meaningful to you. They may not all be meaningful, and sometimes in an experiment it may only make sense to compare group A with group B and then group B with group C, for example. In this case, we'll do all three possible comparisons just to demonstrate. Now, it may be helpful to kind of keep this organized. I think it's helpful to kind of lay out the possible comparisons that you can do in a little table like this, just to make sure you have them all accounted for. It's pretty easy when you just have three groups to determine which ones you need to do, which comparisons are possible, but sometimes it won't be as apparent. So this is kind of a table just to visualize the different comparisons. You can kind of gray out these diagonals because group A is not going to be compared with group A, group B with B, and group C with C, of course, doesn't make sense. You're going to compare group A versus group B, A versus B, A versus C, and then we've got, looking at this row here, we've got group A versus group B represented here, so we can gray that one out too. We also have group A versus group C, that's represented. Group B, the only comparison left is B versus C, okay? So we can gray that one out. So these are the three comparisons that we're going to run, and then it's probably a good idea to organize things a bit beforehand. A versus B, A versus C, and B versus C. Just some places to put the resulting T statistics. Okay, so the formula that you're going to use to calculate this T statistic is up here. Now this is similar to the formula for a two-sample t-test, but the main difference is instead of a pooled variance or a pooled standard deviation, you have this MS error, and this is the same as the MS within groups. Also, the degrees of freedom associated with this t-test is actually the degrees of freedom for the within groups as well, so it would be 33 in this case. Okay, so now it's just a manual calculation. Excel unfortunately doesn't have a nice built-in formula for the Lsd test, but it's fairly straightforward to calculate. So do equal sign. I'm going to make some parentheses for the top. We're going to do A versus B, the averages. We'll do A. I'll go ahead and do B minus A. And then we're going to divide by the square root of a bunch of stuff in parentheses. This is going to be 1 divided by the sample size, which is 12, plus 1 divided by 12. Now, these are all kind of squished together in here, but I've tested this out, and Excel does follow order of operations here. It'll take those two fractions and add them rather than 1 over 13 divided by 12 or something like that. So it'll be 1 over 12 plus 1 over 12. Make sure we've got all the parentheses closed that we need to. And that's it. Okay, so that's one of them. That's one T statistic. And now that we've already done that, we can do some pasting of the formula. We'll just have to make a little bit of adjustment. If you double click on that, you can see we're not selecting the right ones here. We want A versus C. So just kind of move those up. And then copy that formula one more time. Double click it to adjust the range that we've selected, B versus C. Okay. Now this one does show up as negative, but really it's the absolute value of that we care about. Now, so these are T statistics. Notice there's no p-value associated with them, so how do we know which one is significant? Now we can get that p-value from a t-table, but you can also compare it to a critical value. Okay, so we're going to put a critical value here, and Excel does have a formula that can give you a critical value. It's called T.inv, and there is a T.inv that returns a one-tailed p-value, and T.inv.2t returns a two-tailed p-value, and that's the one that we want in this case. Since we're just interested in one of the means being different from each other, different from another one, we'll use the two-tailed probability in this case. Okay, so the probability, what is our probability? We are going to use our alpha of 0.05. Okay, so we're trying to find what is the T statistic that's associated with an alpha of 0.05, where if we get something as or more extreme than that, then we can reject our null hypothesis. It'll have a probability of less than 0.05, so it would be statistically significant. Comma, and then you enter in the degrees of freedom, which in this case is going to be 33. We can even just select that cell there. Okay, so the critical value in this case is 2.03, and two of these, really we can just take the absolute value of this, or if you want to keep everything positive, we can just switch those numbers. It's no problem. It's the same comparison. Two of these are statistically significant, A versus B and B versus C. A versus C, as you can probably guess from this, is not statistically significant. Okay, so we'd conclude that there is a significant effect of group on this dependent variable, whatever it is, and the actual significant differences that exist are A versus B and B versus C. Okay.